Hey, today we're going to talk about Kubernetes for AI, what it means to deploy an AI workload, an AI pod, in a Kubernetes cluster. As you can expect, there's a lot to talk about. And in my previous video, in the first video in this series, we installed all the drivers necessary to pass a GPU device through the host to a virtual machine so that a virtual machine can take control of it. If you haven't watched that video, you probably want to at least go back and watch it, or make sure you have all of the drivers, the VFIO drivers, set up to pass your PCI devices through to your VM, specifically the PCI slot where your GPU is installed. If you don't have that, nothing in this video is going to work. So just be aware of that. In this video, we're actually going to deploy Kubernetes in the hypervisor with a GPU node, one node. Will have control over the GPU device that we installed in the previous video. Cool. So in the previous video, I mentioned that this all came about at KubeCon, where I had the question, how does a pod request and use a GPU device, right? There's a lot of layers between the running pod that we deploy when we run kubectl and the underlying hardware on the node. So that then leads to the next obvious question. Well, how does Kubernetes even know where the GPU is, right? If a pod can request GPU, that means the kube scheduler knows where the GPU is. It knows where to find it. That means there's got to be something on the underlying node that advertises it and is managing that GPU device. So the node, the VM, in many cases, if you're using a hypervisor, the VM has access to that GPU device. Well, today, we're going to answer that question. How is the VM managing that GPU device, right? The thing we installed in the previous video. How is it managing that? And what does it need to install? What does it need to have installed in order to pass that up to the container runtime? So obviously, in order to do that, well, first we need a Kubernetes cluster. And in order to have a Kubernetes cluster, you need a cloud environment, right? Some sort of public or private cloud where your Kubernetes cluster can run. And on top of that, we obviously need a GPU device. Right? Something that a pod can leverage to run its AI workloads. Well, in the previous video, we covered how I installed the NVIDIA 5060 Ti into my Intel NUC. Right? In this video, we're going to work with Proxmox. Now, I'm not going to show you how to install Proxmox, but I will link in the description the video that I followed to set up Proxmox on my NUC, in case you're interested. And then from there, we will install K3s, right? So I'm going to stand up VMs in Proxmox and install K3s onto those VMs so that we have a working Kubernetes distribution. You don't have to go with K3s, right? You could go with something else. I pick K3s because it is generally very straightforward, easy to install, and I've had good luck with it in the past. Now, there is a caveat behind using K3s that we will cover. Oh yes, we will cover, because it took a long time to get past that problem. But other than that, K3s has been really successful for me. So how are we going to do this? Well, as I mentioned in the previous video, we're going to automate everything in this step using Open Tofu. And I will link the repo that I'm using in the description. And if you're not really a fan of Open Tofu, you prefer to use Terraform, I'm pretty sure that I'm not using any tofu specific features in this repo. So you should be able to use Terraform with it, but I haven't tested that out yet. Either way, Open Tofu or Terraform with a Proxmox provider. And I want to thank Eleni Grosduli for all of her blog posts about using Open Tofu and Proxmox. So if you haven't checked out her blog, I will link it in the descriptions. That's 3 links I'm going to put in the description. All right, here we go. So you might be wondering, well, which Proxmox provider? There's a lot of them. Yes, there are. And not all of them are good. The one that we're going to use is this one, BPG Proxmox. I found it to be very feature complete, right? Everything that I've wanted to do in Proxmox is built into this provider, and it's updated rather regularly. So you can expect regular maintenance and regular commits going into it. So let's take a look at my Proxmox virtual environment. Cool. And you can see I've got one host in my data center, my Intel NUC, the one we've been talking about. And I've got one long-term tenant virtual machine. It is Cisco Modeling Labs. It's shut down, and we're going to stand up new VMs to constitute my Kubernetes cluster today, right? Specifically 4 new VMs. Moving on. Let's go into the Open Tofu repo and see what we're working with code-wise. Here we are in Cursor. All right. You can see I've got my provider set up. the Proxmox BPG Proxmox provider, cool, and the HashiCorp random provider. That's going to allow us to create some secrets like the K3's token that will be passed through to all the servers so that they can authenticate with each other. The other thing worth pointing out, I'm not authenticating with an API token here, right? I'm authenticating into Proxmox with username and password. That's valid. Most people would say it's insecure. They are right. But the thing you want to keep in mind is authenticating with an API token does not always grant you the permissions, doesn't grant you all the permissions that your user has access to. Specifically, passing through a PCI device to a VM. That will get 403'd if you try to authenticate with an API token. I learned that the hard way. So that's why I'm using username and password. There you go. Let's check out main.tf. So this is my main entry point to my resources that I'm creating. Okay, so the first thing I'm doing, downloading Ubuntu. That's the flavor of Linux I decided to use for my VMs. You can probably use a different flavor. I have no idea how well it'll work, probably pretty well, but this is what I'm going with. Creating the K3's token, creating an Ubuntu password for accessing the VMs, if I want to do that through the console. And then here's my first module, right? I'm standing up the K3's server. This is the control plane VM, right? I'm passing in a lot of the standard stuff you'd expect when you're standing up a VM. Things like which node to deploy it on, the only one. Which cloud image to use, Ubuntu, right? How much storage, how many CPU cores, how much memory. Now we're talking about K3's, right? What's the K3's token that we're going to share between all of our nodes? And what's the version we want to install? Very cool. So if we come into the main file for that module, we can see, yep, standard stuff you'd expect when setting up a virtual machine as a resource. You have our CPUs, our memory, our disk. Down here is something I want to point out. I'm using DHCP to set the IP for this VM. That's important to point out, and I'll tell you why in a few minutes, but let's keep that in mind. I'm using DHCP. Down here, I'm creating a cloud init file, right? A user data file, whichever one you want to call it. And so that's going to be where K3's is actually installed. When this boots up, it will make sure K3's is installed. What does that look like? It looks like this, right? Here's my user data for the K3 server. At the top, you have some standard stuff. Change the password for Ubuntu, set some SSH keys. And here, we're going to wait for the network to be active, right? Or wait for network connectivity. And down here is where we're installing K3's. And we're passing in the server flag. So we're saying that this VM, the one that's running this cloud init, is going to be the server. Very cool. We're going to wait for K3's to be ready. And then we exit. Pretty straightforward. The workers, if we come back to the main, the workers have basically the same setup in the resource definition. The only key differences here, right? I can set a count for how many workers I want to deploy, and we'll see in a second. There's 2. I'm deploying 2. And the other thing worth pointing out is the workers get the K3's server URL. That's the IP that's going to get defined when the server VM stands up. So we're passing that through here. And the reason we're doing that, come into user data in the worker has a bit of a different setup script. Okay. Yes, we're going to set SSH keys and change the Ubuntu password. Very cool. We're going to wait for network connectivity. Very cool. But here we're saving the server IP as a constant. Why? Well, once we're sure that server is ready, we can install K3's and point to the control plane URL. This is where we establish that the VMs running this script are worker nodes, and they're connecting, they're calling back into the cluster that's already been established on the main node, right, on the server node. So that's how they're registering. They need that IP. So let's talk about DHCP. If we're leasing an IP when we stand up our server node, right, anytime you shut these VMs down, you risk losing the IPs assigned to them. DHCP, right? You're leasing it. It's a temporary IP. If you stand the VMs back up and they get assigned a different IP, especially the server, but even the workers, things won't work as you expected, right? Things won't work as the last time you were here. So that's something to keep in mind. I chose DHCP because I really don't want to mess with my router for some VMs that I can just totally blow away and stand back up again. It takes 10 minutes for the script to run end to end. That's as much as brewing a pot of coffee, and I'm fine with it. It's up to you if you would rather set static routes so that you can shut these VMs down and stand them back up without the risk of totally breaking your Kubernetes cluster, right? But it's something to keep in mind and worth knowing about. Okay, very cool. So we'll come back over to main. And we'll scroll down to GPU worker. Now, this, again, has a lot of the same things that we passed into the server and the workers, right? Including, somewhere around here, the K3 server URL. But we're also passing in some other stuff. GPU PCI ID, right? Which is a variable that I'm passing in, and I'm defining that. I'll show you what that looks like in a second. And NVIDIA driver version. That's also a variable that I'm defining, and I'll show you where I got that in a second. So let's come into over here, K3's GPU worker.tf, right? So all of the standard stuff that you would expect to see, right? Passing in your CPU count, passing in the memory, passing in disk. What is this right here? Host PCI. This is where we're telling Proxmox through Open Tofu that we're going to attach a host PCI device to this VM, which we would not be able to do if we hadn't set up VFIO in the previous video to manage the GPU device, right? That was the whole thing. That's the reason that previous video exists, was so that we can define this block right here. And in this block, we're saying host PCI 0. That is a string that we're making up. You could probably call it anything, but that's a key that Proxmox is going to use to keep track of where this PCI ID has been assigned. And if you're wondering, well, what does that PCI ID look like? Well, let's go into TF-vars and I'll show you. Now, this is an example. This is not my real TF-vars. I don't have my password as your password here, right? This is an example that I'm going to include with the repo. Mine is different, has my password in it, and I'm not sharing that with you. Down here, where are we? Right here. This is where we define the PCI ID. Okay, and you can see it's got the domain, PCI slot, device ID, and function. Where did I get that from? Well, let's take a look at the command line. I'm already SSH'd into my NUC right now, and I'm going to run this command, lspci-D and NK. Capital D means include the domain of the PCI device when you list it. And N is name and number, and K is driver. We're going to grep on NVIDIA. I probably don't really need K. Anyway, we're going to grep on NVIDIA so that we only show the NVIDIA devices. And when I hit enter, we will get the domain slot, PCIe slot, device ID, and function. You can see that this device has two functions, right? Graphics and audio. Well, we're passing right here, we're passing the graphics function in as the PCI ID, right? That's where we're getting this from. Next, I want to point out NVIDIA driver version. So we can put that away. NVIDIA driver version right here. There's a lot of resources out there on installing the NVIDIA drivers, and not many of them mention that there's compatibility issues between different GPU cards and different driver versions. So the way to get around that, the way to find out which version works for you, come to this website. Official GeForce drivers, manual search, and you can see here. Hold on, let's not get ahead of ourselves. I searched for 5060 Ti right there. That's my card. And down here are the results. And I just picked the first one, 580, right? Been updated relatively recently. And so this is how I found out which version worked for my card. You should do this. You should run this search to find out which version you need to pass in. So that's how I set this here. And then last thing I want to point out in terms of variables that I'm passing in, we have our node sizing, right? So my server is getting 4 CPU, 4 gigs of memory. I've got 2 CPU and 4 gigs per worker, and there's 2 workers. And down here is my GPU. It's getting 6 CPU, that's a lot, and 16 gigabytes of memory. We're going to talk extensively in one of the future videos about how much memory it takes, just memory within the VM, how much memory it takes to run an AI workload. I was really shocked. I mean, I expected a lot of memory on the GPU. I did not expect how much memory I had to use and how many times I OOM'd in my VM. So we will talk about that in a future video. Moving on, let's jump into user data because this is where things get weird. So it starts out looking mostly the same, right? We're setting the Ubuntu password, we're passing in SSH keys, we're going to wait for the network, and then we're going to install prerequisites. Why? Because then we have to install the NVIDIA driver. Now, you might be thinking, if you've got experience with this sort of thing, wouldn't the GPU operator just install the drivers? In some cases, yes. In my case, no. And we'll talk about why in a second. So I'm installing the NVIDIA driver, and then once that's been validated, I can install the NVIDIA Container Toolkit. Now, this is cool, right? These two things working together. NVIDIA driver allows the VM to know what it's doing with the underlying GPU. The Container Toolkit allows the container runtime to access the GPU. This answers that question in the beginning, right? This is where all the power is. This is where the VM says, I am the VM that controls the GPU. Come to me, AI pods. That's this right here. So once we have those things installed, we can install K3s. This is where I had a lot of problems. We're going to reach out to the K3 server, right? Our server node to make sure it's working, install K3s, and then we're going to mess with containerd. See, in many common setups, the containerd instance that is used to run containers on your node is the default that comes with your Linux box. The thing is, K3s packages its own containerd. If you were to try and install the NVIDIA libraries that are required for the Container Toolkit, if you were to try to install those with the GPU operator and let the GPU operator and NVIDIA do all the work for you, it would install those libraries for the wrong runtime because K3s packages its own container runtime, its own containerd, right? You can see it's at this path, which didn't exist until I installed K3s up here. So it comes with its own containerd, and that means you have to specify that containerd when you're installing all your NVIDIA libraries. So down here, right, we're doing all that. We're making sure that the NVIDIA runtime has been set up, and we're setting that as our default runtime in our Linux node. This is worth pointing out because what this means is that every pod that runs on my node is going to get the NVIDIA libraries. For the most part, that should not be a problem. You can get more fine-grained and specify runtime per pod. I didn't really feel like doing that. So everything's going to get the libraries whether they use them or not. But that also means my AI containers, my AI pods, are going to get those libraries too. So they'll be able to talk to the GPU. Rockstar. So then we restart the K3's agent and we have the GPU worker node join the cluster. How cool is that? So not very cool if I can't prove that it works, right? So let's prove that it works. I come into this tab and you can see I've already got Tofu apply set up and I'm going to run it. And while that's running, while that's doing all its stuff, I want to come over to this script right here. When I run this script, it's going to SSH into the server node and copy down the kubeconfig, right? K3 sets up its own kubeconfig. So this is going to copy it down to my local file system so that I can kubectl into this cluster. In order to do that, we have to wait a few minutes. Okay, that worked. And look, I've got two worker IPs, but wait a minute. Where's my GPU worker? I don't know. Let's find out what happened here. I'm going to run my SSH script, right? I'm going to get that kubeconfig. So I'll do that. It's copying. Very cool. I'll clear this to come back to the top and I'll export the kubeconfig. Awesome. So now I'm pointing to the kubeconfig I just copied and I'll kubectl get nodes. And there's only three. There's the server and the two workers. Why? What happened? Well, if we come into Proxmox over here, we can see I've got all four VMs. They're all stood up and they're all running. The thing is, the K3's GPU worker is still booting, right? It's still running that cloud init script that requires all this stuff, all these things we're going to install. So that's why it hasn't joined the cluster yet. It's still installing drivers. It's still installing the container toolkit, and it's going to keep doing that before it's able to actually connect to the cluster. So we got to wait for that, and we'll wait a few more minutes. Okay, a few minutes have passed, so let's run get nodes. There they are, all four of them. How cool is that? We've got our server, 2 workers, and the GPU worker. Now, the important thing is to actually find out if the GPU worker has the GPU. In order to do that, we're going to SSH into our GPU worker node, and we're going to run NVIDIA SMI, NVIDIA System Management Interface, I think. So I'm going to pull down the Ubuntu password so that I can SSH in from the Proxmox console. So I'll paste this in here, tofu output raw, Ubuntu password, and I'm going to pipe that into pbcopy. All right, now I've got it copied. Come over to the Proxmox console, and I've got my worker node, my GPU worker node. Cool. Open up a new console window. Very nice. Starting terminal interface, stuff and stuff. All right, and I'm going to log in as Ubuntu. Password, paste that in, and now I'm in. So, can I run NVIDIA SMI? NVIDIA SMI, what's going to happen? I hit enter. Here it is. It's got all the drivers set up for my 5060 Ti. So my VM, I'm SSH into my VM. Oh, K3's GPU worker 0. I'm SSH into my VM, and it's got all the necessary software to manage this 5060 Ti GPU. So that's the underlying node, right? The VM is all set up, but the cluster isn't. The cluster still doesn't know how to run AI workloads because it doesn't have cluster-wide software to be able to advertise that there's available GPU and then subsequently schedule AI workloads on pods that request that GPU. So that's what we're going to cover in the next video. If you like this video, please feel free to drop a like. If you want to see more videos like it, especially the rest of this series, consider subscribing. And if there's stuff that you want to see that I'm not covering, or if there's other things that you think I should have included in here that other people should know about, please leave a comment. This is a community effort. I am not an expert, so I want to hear what you have to say about how to set this up, how to get it running, how to make it more production ready, etc. Thanks for watching.